Hi, in today's lesson we're going to look at parallel lines and transversals, and then we're going to look at a converse of our theorems that we discovered in the last lesson. Okay, so in the last lesson we learned that if parallel lines are crossed by transversals, then the following theorems are true. We have our corresponding angles theorem that says if a transversal intersects parallel lines, then corresponding angles are congruent. Now this is important. We spent a couple days working on if-then conditional statements for this reason. It's important to notice that, remember, your hypothesis always has to be true in order for the rest of the sentence to occur. So if transversal lines intersect parallel lines, that has to be true. You have to have parallel lines for this to work. If you don't have parallel lines, then it's not going to work. But when you do have parallel lines, I know that means that I'm going to have corresponding angles being congruent. Remember, corresponding angles are angles that are in the same position. So if my lines A and B are parallel, which there it says here they are, and then even in my picture it shows that they are, all my corresponding angles are congruent. There are 4 pairs of corresponding angles. I'm just going to pick one of them and mark one for our purposes of our example here. Okay, so I'm going to go, remember, corresponding means they're in the same position. So I'm going to go up and to the left from each intersection. So these 2 angles are congruent only if angle A and angle B are congruent. If they're not congruent, or if angle A and angle B, sorry, I lied, not angles. If line A and line B are not parallel, then I can't say this, right? It has to be parallel in order for my corresponding angles to be congruent, okay? So then my alternate exterior angles theorem starts with my hypothesis: if a transversal intersects parallel lines, then my alternate exterior angles are congruent. Okay, so again, the hypothesis has to be true. So I have to have parallel lines. And if I have parallel lines, then I can show that my alternate exterior angles are congruent. So when I look at this one, my alternate exterior, there are 2 sets. I'm just going to show one. That's going to be here and here. Remember, alternate exterior means they're on different sides of the transversal, which would be this line here. And then exterior means they are not in the interior, right? Remember, this part's the interior. Okay. The next one, alternate interior angles theorem, if a transversal intersects parallel lines. So here's my hypothesis. If a transversal intersects parallel lines, then alternate interior angles are congruent. So I cannot say the orange part unless the blue part is true. So I have to have parallel lines in order to say that my alternate interior angles are congruent. So alternate interior angles looks just like exterior, except instead of outside, they're inside. So they have to be on different sides of the transversals, but on the inside. So there's 2 sets. I could either pick the left or the right at the top intersection, and then I just have to make sure I do the opposite side on the bottom intersection. Those are alternate interior. I know they are congruent if angle A and angle B are parallel. Sorry, line A and line B are parallel. Okay? So these angles can only be congruent if the hypothesis is true. Okay? And the last one, same side interior or consecutive interior. It gets 2 names because it's special. Angles theorem, if a transversal intersects parallel lines. So again, I have to have parallel lines before I can say this sentence is true. Then the conclusion is if I do have parallel lines, my same side interior or consecutive interior angles are supplementary. Remember, this is the special one. This is the one that likes to be a little bit different. Okay, so this one, they're going to be supplementary. So notice I'm not going to mark them the way I did these. I marked these the same because they're congruent. I marked these the same because they're congruent as each other. I marked these with the same arc mark because they're congruent, but down here these wouldn't be congruent, and I do want to show that they have to be supplementary, so I'm just going to pick 2 values that would be supplementary. I can pick they're on the interior because they're interior angles, so they have to be in this shaded area. and they have to be on the same side of the transversal. So they can both be to the left or they can both be to the right. And I'm just going to pick some numbers. I'm going to go with 50 here and 130 there. Okay, and again, those are only that's only gonna happen if my lines are parallel. If I don't know I have parallel lines, then I can't assume that's gonna happen. Okay, well, look at my next question. It says, what about the converse of these theorems? So remember, converse, the key word for converse is switch. Remember, we did converse, inverse, contrapositive. So that means instead of if a transversal intersects parallel lines, I'm going to start with if the same side interior or consecutive interior angles are supplementary, then a transversal intersects parallel lines. We're just going to switch everything around. So look, that's what I have right here. Okay? So this time, my corresponding angles converse. So notice what happened. Instead of starting with a transversal intersects parallel lines, that is now my new conclusion. We switched it on each of these, right? A transversal intersects parallel lines is now the conclusion. A transversal intersects parallel lines is the conclusion. And a transversal, after the word then, intersects parallel lines is the conclusion. And what was my conclusion moves to the front. So before it was, for my corresponding angles theorem, it started with a transversal intersects parallel lines, then my corresponding angles are congruent. The converse switches those if corresponding angles are congruent. Okay, so notice in my picture I don't have those little parallel triangles. Remember before I had the parallel triangles, I knew in advance that I had parallel. Okay, we can use the converse to prove that even if it's not marked parallel, if I can show that my corresponding angles are congruent, if I show this first hypothesis is true, then that means the conclusion is going to be the old hypothesis, and it's going to be true. A transversal intersects parallel lines. So even though I don't have the triangles on here that show me they're parallel, I can know that because my corresponding angles, 45 and 45, because they're congruent, I know that line A is going to be parallel to line B. Okay? When I look at the second one, a transversal intersects parallel lines, then alternate exterior angles are congruent. We switched it around. And now, even though I don't know if I have parallel lines, I can prove I do have parallel lines because these alternate exterior angles are both 135. So because they're congruent, even though I don't have any information here about line A and line B, I can prove that because alternate exterior angles are congruent, line A is parallel to line B. Okay, that also works for my alternate interior angles instead of my exterior angles. So this time, my conclusion moved to the front. Alternate interior angles are congruent. So that's where I'm starting. My alternate interior angles are congruent. And that tells me when these alternate interior angles here are both 50, that means even though it doesn't show me that my lines are parallel, I can now prove that those lines are. Indeed, A is parallel to B. And then the last one, the one that has to be different because it has two names and it likes to think it's special, it's my same side interior or my consecutive interior angles converse. So we took the old conclusion, same side interior, consecutive interior angles are supplementary, and we switched it with the old hypothesis, then a transversal intersects parallel lines. So if I can show that my same side interior angles are not congruent but supplementary, 150 plus 30 does equal 180. Okay, so once I can show that they are supplementary, then I can say that A is now parallel to B. Okay? All right, in the next video, we're going to stop here and we're going to look in the next video about how to apply the converses of these theorems, and when you know when to use the theorem and when to use the converse. Okay? Thank you so much for watching.